All right, so we have at least 35 performers of the Big Tent Circus are in the grand finale. Some pile into cars while others balance on bicycles. 7 performers are in each car and 5 performers are on each bicycle. Draw a graph showing all the combinations of cars and bicycles possible for the finale. What was my important information?
At least 35 performers.
So at least 35. So is that a greater than or less than sign?
Greater than or equal to. Yeah, greater than or equal to.
Greater than or equal to 35 performers. Okay. What's next? What else was important?
The 7 cars and bikes.
Cars and bikes. So we'll say X equals cars. And we'll say Y equals bikes. Guys, you always have to specify which one's going to end up being which. So on this graph, I'll number
Which one is which?
of cars, number of bikes. 0. All right. Well, now I have to finish writing out this inequality. What do I do?
Cars plus the bikes.
Good.
7x plus 6y. Or 5y. Yeah.
7x, excellent, plus 5y. Now I have my inequality. What would you do now in order to graph this? Yeah, Ryan.
I'm trying to get the Y alone.
Okay, we can definitely do that. Get the y alone. I can do minus 7x to both sides. I'd have 5y is greater than or equal to negative 7x plus 35. Continuing on, divide everything by 5. Y is greater than or equal to negative 7 over 5x plus 7.
I'm still confused why you have to divide 5 by everything.
Y you do?
Yeah.
So what would I have to get y alone, right?
Yeah.
So I need to get rid of 5. Okay.
What would you do instead of doing that? Getting y.
So another thing that you can do is find the x and y intercepts. All right. So this is fine, but you have another choice. I can solve for the x and y intercept. So for the x-intercept, I plug in 0 for y, and you'll notice that basically just goes away. I don't use an equal sign for this. 7x equals 35, x equals 5. Then I can do my y-intercept. Plug in 0 for x. I want to use the equal sign still. 5y, oh, that's not a 5. 5y equals 35, and then y equals 7. Either of these will work. Okay? You don't have to do both, guys. It's one or the other, so make sure you write down the word or. Now, the reason why I like this one better for these kind of problems is because then I don't have to worry about the interval so much.
Why?
So when you do this problem, okay, if you're trying to do it by counting spots, they need to have the same interval on both sides. So if this one goes by ones, this needs to go by ones. Okay?
It doesn't matter which one the variable is. Can you actually have bikes with an X?
If I made bikes X, I need to make sure I label it. That's why you had to label it here. See how I had a number of cars down here?
Yeah.
You would write number of bikes. Okay, so that does not matter unless they tell you. There will be times they'll say bikes, parentheses around it, X. Okay? So I have this. Again, the reason why I like this better is because they tell me the y-intercept is 5, so I know I need to go to 5. Here it tells me the x-intercept is 5. The y-intercept is 7, so I need to go up to 7. So that's why I like it. Okay. This, you just got to hope that it's going to be the same interval. And it is.
So would it be y is greater than or equal to 7 if you do a y-intercept?
Just do it like this. Because what that means is when we go to 7, now I'm going to skip every other one because I think it's 15. Oops. So watch, I'll go 1, 2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6.
Oh, so that's how we're graphing it, alright.
See, if I do it like this, I can do 0, 7, 5, 0. And then now you have to go back to your inequality. So this is why you kind of do want to look at it like this though, because it tells you where you have to shade. I'm going back and forth, I know. Figuring this out as we go. No. With these problems, it should never be negative. It should always be like this. Yeah. Then you'll be fine. If you did this, you'll be fine if you wrote this out because it'll still be greater than or equal to no matter what, or less than or equal to. It won't flip. But you know how it flips when we divide by a negative?
Yeah.
You shouldn't have negatives for these problems.
Alright.
I'm going to draw a solid line connected to 2 dots. If I turn my inequality, which way would I shade?
What would I shade?
Remember you turn it to, oh, you weren't here for that. So for these, we turn them to the left. All right, and which way is the point when I turn my inequality to the left?
To the left.
Which way is it going to point? If I just a little bit, it's going to point up. So I shade up. I shade above the line. All right. Now it says showing all the combination of cars and bicycles possible for the finale. So what that means, and this is what happens on the Keystone, guys. They'll ask you, all right, tell me some combinations of the bike and the cars, how many there could be. Well, if I go by the line, I can see that with, let's say, 1 car, 5 bikes, about. Or I can choose any value in the shaded area. I can go here. I can say 3 cars and 4 bikes. And that'll be how many people I can have. So it tells you, all right, what kind of combinations you can have. There's a large number of combinations that we can have. All right, it's kind of nice that they give you that. That's why we do inequality graphing, so we can know all the possible combinations that are needed that we can have. Kind of gives us a big picture. All right, questions on that? Anytime you guys have a word problem, this is how your graph needs to look. All right, when it's a word problem, it'll always look like this. Yeah.
For like these type of graphs over here,
Yeah.
could we still use that form on the bottom one that's intercept and y-intercept?
Yes.
Or would it be the best solution?
No. The reason why it's not going to be the best, I hate updates. The reason why it won't be the best is because if your y is negative, it changes the way, where'd everything go?
Wait, what do you? Oh, there it is.
The reason why it's not the best idea is if you look at, are any of us like it? No, none of them are like that. Because if any of them are negative, it'll mess up your answer. So you always want to get those in y equals. It makes life a little bit easier. Especially when we get to where we have to graph 2 of them on one graph.
Oh, so much.
They're not bad.
Especially these being.
All right. Now we get to absolute value inequalities.
Yay.
So, same thing as when we grabbed absolute value equations, except for now we have to decide if it's solid or dotted and where to shade. Okay? Same thing, guys. First step is get y alone. Next step, same as when we did absolute value equations. Find the vertex. So whatever's inside the absolute value, we set equal to 0. We solve for our vertex. Choose a number smaller and larger than x. Plot the points. All right. And just go from there. And we'll talk about the shading. So is my y value alone in A? Yeah. The y is alone. There we go. Yeah, the y is alone. So now what we can do is we can take whatever's inside the absolute value and set it equal to 0. So x minus 4 equals 0. X equals 4. Make my xy table. 4. What's my y value for my vertex?
5.
5. Okay, I need a value smaller and a value larger.
3 and 5.
3 and 5. I plug them in. I'll do this with an equal sign. 3 minus 4 plus 5, -1 plus 5, and that's 6. Now I'm expecting both of my answers to be 6. Y equals absolute value 5 minus 4 plus 5, 1 plus 5, and that is 6. Any questions so far? I have to plot all 3 points. Yeah, it should make a V. 1, 2, 3. 1, 2, 3, 4, 5, 6. And then 4, 5. And then 5, 6. So far, so good. Is this a solid or a dotted line?
Solid.
Solid. Now, if I'm looking at my inequality and I turn it counterclockwise to the left a little, which way is it going to point?
Down.
Down. Now, here's the question. Which side is down?
2.
Why 2?
Huh?
Okay, it is under it. Basically, the way I, again, keep looking at it, down. If I tried standing, I could stand on the inside of this. But on the outside, I couldn't. But yeah, that is down. So 2 is the answer. Good. Now, Jillian, I write down 1 and 2 on mine, so you guys can give me the answer of which area to shade it in, instead of just saying there.
Alright.
All right, you don't have to write down 1 and 2. You just have to make sure you shade it. Any questions on that? Okay. If we look at B, who can tell me some things about B without us even graphing it, without doing anything, Brian?
There's a negative from the absolute value.
Mm-hmm. What does that mean?
That means like the one's upside down.
It's going to face down. Good. Excellent.
Wait, why do we put the sign?
Huh?
Just to see where we shade.
See where we shade. It's not flipping. We're just turning it a little bit to see where we shade. All right. You can do test values, but I find that this is a lot easier. All right. So we know it's already going to be facing down. I'm going to take whatever's inside my absolute value, set equal to 0. X equals -2. I have my XY table, -2, -3. All right. We should be able to do that part pretty fast. Now, when it comes to choosing new values, what values would you choose? What values would you choose?
I would say -4 and 0.
So I was gonna say.
You want to use -4 and 0?
Yeah.
We can do that.
Just to keep some separation.
Yeah, they're equal distance apart. And then I have, we'll do -4 plus 2 minus 3. I forgot the negative sign in front. There we go. -2 minus 3. That's going to be -2 minus 3, and that's -5. So when I plug in 0, I'm expecting a -5 as well. y equals negative 0 plus 2 minus 3, negative 2 minus 3, negative 5. Any questions so far? Guys, plug in both values and check them both. All right. Even if they are equidistant, don't just assume it's the same answer because you make mistakes. We know this. Any questions so far? All right. So I'm going to erase this. Everybody has this copy down? Okay. I have to erase it to graph it. Good? If I do this, it'll probably, still covers the screen. Negative 4, negative 5. Negative 4, negative 5, negative 2, negative 3, 0, negative 5. That's what it was, right?
Yeah.
Okay. So negative 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. Negative 2,
3.
negative 3, and 0, negative 5. So like Ryan said, oops, I forgot to check if it was dotted, solid or dotted.
It was
Like Ryan said, it's facing down. Which way is it, solid or dotted?
dotted.
Dotted. Be careful, guys. Make sure it looks dotted. Which way is it going to point?
Up, 1 or 2.
Up. So here's 1. Here's 2. Which one do we shade?
1.
All right. That's where you could probably, if you're trying to, you can stay on top of the graph. Any questions on that? Not too bad?
This is it.
That's good.
One more to go. Oh.
Is all we have? Is one more to go?
Yep.
Nice. Let's knock this one out of the park. All right. What I'd like you guys to do is get y alone. All right. I'll give you just a moment to do that. Get y alone. Don't go further than getting y alone, guys. I want to make sure nobody makes any mistakes. Give you just a few more moments. All right. Who thinks he got this? All right, Ryan. First step.
You gotta subtract 3 to both sides.
Excellent. So I have 2y is less than or equal to negative x minus 5 minus 3. And my next step?
And then you gotta do x minus 5 equals 0. Oh no, divide 2.
Divide 2 to everything. Hello, Mr. Pine. Okay. All right. No problem. All right. So I have this. Now the way this gets written, guys, be careful. It's negative 1 over 2 in front. X minus 5 minus 1.5. Now you can leave it negative 3 over 2, but that's easier to graph. Does everyone know how I got the negative 1/2 in front? Okay. Now I can take whatever's inside the absolute value, set it equal to 0. Get my x alone. Set up my xy table. And it's negative 1.5. All right. I need a value smaller and a value larger. Can somebody give me one?
0 and 10.
Nah. Why is it 0 and 10? Why not?
10's a pretty big number.
Yeah.
I don't know if we have 10 spots on the graph.
4 and no, not 4.
4 is actually a good. Well,
Three.
negative 4 is a good one.
3 and 8.
Oh wait, this is 5. So 4 is a good one.
Oh no, 3 and 7.
3 and okay. That actually is even better.
Good job, dude.
Reason why it's better because we're multiplied by -1/2, so that'll actually give me a nice number. So I'm going to do y equals -1/2. Ask value 7 minus 5 minus 1.5. Y equals -1/2. Ask value of 2 minus 1.5. And then that's going to give me -1 minus 1.5. And that's -2.5. I don't have time to do the 3-1 guys, so I'm rushing through that. I'm going to graph these. 1, 2, 3, 4, 5, 6, 7. 1, 2.5. 5 and -1.5. And 3 and -2.5. Okay? It's facing where it needs to face, going down. Looking at our inequality sign here, which way is it graphed? Which way is it shaded, I mean? Add 2. All right. Any questions? Guys, your homework will be 11 to 16, all on the same page. 11 to 16, all on the same page.